7, and we're going to be dealing with, it's called reciprocal trig functions. Now, reciprocal means the opposite. Remember that, flipped over a fraction. So remember that with the unit circle, before we get into reciprocal functions, just remember, when using the unit circle, we're talking cosine and sine values. We're looking at x and y points around the unit circle, and x is our cosine and y is our sine values. Now, we didn't learn how to graph tangent, but we do need to know about tangent. So tangent is simply sine of theta over cosine of theta. Sine of theta divided by cosine of theta. So that means you can find tangent of theta on the unit circle by taking your y value divided by your x value. So now you know sine, cosine, and tangent. Using the unit circle, you can find all three. So we're going to practice finding tangent of certain values on our unit circle here. So tangent of pi 6. So once again, I'm going to locate pi 6 on my unit circle. It's right here. I'm using these points. So you'd say to yourself, okay, well, I know that tangent of pi 6 is equal to sine of pi 6 divided by cosine of pi 6. Sine over cosine. So what is sine of pi 6? What is sine? Sine are our y values, you guys, right? 1/2. So we have 1/2 on top. And divided by, on bottom, we have cosine at pi 6, which is our y values. Our x values. So on bottom, we have the square root of 3 over 2. Now today there's going to be a ton of algebra involved, and some of your algebra is still, it's getting better, it's still a little rusty, so just pay really close attention to what I'm about to say. So guys, do you see how we have a fraction divided by a fraction? Dividing fractions is easy as pie. You flip the second fraction and multiply. So to simplify this, we're going to write it as 1/2 times pi. We flip the second fraction, so 2 is on top, the square root of 3 is on bottom. Is everybody good with this? So then we would multiply straight across, but look, don't our 2's divide out? 2 over 2 is 1 over 1. So on top, we have 1 times 1, which is 1. I need to give myself some room to write next time. And on bottom, I have 1 times the square root of 3, which is the square root of 3. Now also, not only that, but we have to be able to look at our answer and say, is the answer appropriate? Is it in the most simplified form? Can anyone tell me what the problem is right now? Okay, so that is my answer, but I've got to simplify it. We can't have a radical in the bottom of a fraction, so we rationalize the denominator. So we're going to multiply the bottom by the square root of 3 and the top by the square root of 3, because isn't that just a fancy 1? Okay, so what's on top? 1 times the square root of 3 is the square root of 3. And on bottom we have the square root of 9. 3 times 3 is 9, which is what? 3. Does everybody see how I took care of the radical in the bottom? So this would be how we would write the final answer. Questions on how to find tangent. One more of finding tangent. Tangent at negative pi fourths. Now because it's negative, we learned a little trick. So positive pi fourths is up 2 tick marks. So negative pi fourths will be down 2 tick marks. So we're looking right here at these xy values. We know that tangent is sine over cosine, so we know it's going to be y divided by x. So we have negative square root of 2 over 2 divided by y, which is square root of 2 over 2. Dividing fractions is easy as pie. Flip the second fraction and multiply. So I'm going to multiply by flipping the second one, 2 over the square root of 2. Now let's see what happens here. What's the square root of 2 divided by the square root of 2? 1, right? Are you following me, guys? A lot of algebra today. What's 2 divided by 2? 1. So negative 1 times 1 is negative 1, right? On top, 1 times 1 on bottom is 1. What's negative 1 divided by 1? Negative 1. So tangent of negative pi fourths was negative 1. Questions on how to do tangent? Okay, so that was just a small piece. That wasn't what we were learning today, but we had to get that basis first. Okay, so today is 6-7, reciprocal trig functions. So now we have to know what cosecant is, secant, and cotangent is. So you guys this should not look brand new to you. You should have seen these at least in secondary 2. But these are the reciprocal trig functions. So guys, we know sine of theta, we know cosine theta, tangent theta. You'll have to just kind of get this memorized. I'll kind of give you a little hint on how I kind of remember. So cosecant, that's how you say this one, cosecant. But they don't write it out, it would be cosecant anyways. Cosecant theta is equal to 1 divided by sine of theta. Does everybody see that? You'll want to write that down for sure. Secant of theta is equal to 1 over cosine of theta. They're equal. So you can always take 1 and divide it by cosine of theta. And then cotangent of theta is equal to 1 over the tangent of theta. So do you see how these are reciprocals? Reciprocals? That's why they're called reciprocal trig functions. Because cosecant is equal to the reciprocal of sine of theta, which is 1 over sine of theta, flipping it over a fraction. Does everybody see why they're called reciprocals? Because secant of theta is the reciprocal of cosine of theta, because we take cosine of theta, flip it over a fraction, which would be 1 over cosine. Okay? And then cotangent, same thing. It's the reciprocal of tangent because we flip it over a tangent over a fraction. Now, a lot of people tend to get these two confused. I even catch myself sometimes saying, oh crap, which one is cosecant, 1 over cosine or 1 over sine? So do you see how it starts with a C?
Yeah.
You go with the opposite. So sine doesn't start with a C, does it? So we use 1 over sine. This is a dumb little trick I use, because sometimes I'm like, secant, crap, is that one sine or cosine? So see how this one starts with an S? It's the opposite with the reciprocal, so it would be the cosine. C starts with not S. Does that make sense? Because a lot of people say S, so it must be sine. Do you get what I'm saying?
Yeah.
It's just a little trick I use. Otherwise, you can just memorize it. And then cotangent, literally cotangent says the word tangent in it, right? So that one's pretty easy. Okay, so now let's just use we're just going to use our unit circle to find these values. It's not much harder, just a little bit more algebra involved. So it says, find the exact value of cosecant of pi over 6. So you have to ask yourself, what is cosecant? So cosecant of pi over 6 is equal to 1 over, it started with C, right? So we do opposites, it's 1 over sine, right? So we're really looking at 1 over sine of pi 6. So then you say, okay, I want to know what is sine of pi 6. So I locate pi 6 right there. We know that sine is the y value, right? So really we have 1 divided by the sine of pi 6 is 1/2. So we have 1 divided by 1/2. Does everybody see how I did that? Now a lot of people can't simplify from here. Their algebra skills are not there. So I need you to all listen very carefully so I can kind of help you out with this. Wasn't it 1/2 on bottom? So it was 1 divided by 2 on the bottom, right? And on top there's a 1. So isn't 1 on top technically 1 divided by 1? Isn't that the same thing? So we really have 1 divided by 1, and that's divided by 1/2. Does everybody see how I rewrote it? Okay, so then I can say to myself, dividing fractions is easy as pie. I flip the second fraction and multiply it. So then we're going to simplify this. We're going to flip the second fraction, so I put a 2 on top and a 1 on bottom. Does everybody see what I'm doing here?
Yes.
Multiply straight across. 2 times 1 is 2, divided by 1, right? Which is 2. So the cosecant of pi over 6 was equal to 2. So it took all that work just to get an answer of 2. Not super hard by any means, but just take some practice. Let's do another one, then I'll let you just go. Okay, secant of negative pi 6. So the first thing I say, what is secant? So secant is 1 over, we always go opposite, so the cosine of, so I should have wrote secant of negative pi 6 is equal to 1 over cosine of negative pi over 6. So then I locate negative pi over 6. So 1 up, 1 down, that would be this. We know that cosine is x, so I'm highlighting x. Okay, I'm looking at that. So really we have 1 divided by the square root of 3 over 2. Now once again, a lot of people can't simplify this, and if you try typing it in your calculator, it's not going to do it for you. You have to have algebra skills. Your calculator will give you a decimal, not acceptable. So you have to say to yourself, okay, isn't this on bottom, the fraction kind of connected for right now? Like, isn't it the square root of 3 over 2 on bottom? Yes, we have a 1 on top. So don't we technically have 1 divided by 1 on top? And that's divided by the square root of 3 over 2. Then dividing fractions is easy as pie. You flip the second fraction and multiply. So I put a 2 on top, square root of 3 on bottom, right? Multiplying straight across, I get 2 times 1, which is 2. 1 times the square root of 3 is the square root of 3. Now, that's my answer, but is it appropriate? No, we can't have a radical in the bottom. So we're going to rationalize the denominator. So I'm going to multiply the bottom by the square root of 3 and the top by the square root of 3. because that's just a fancy one. I haven't changed anything. So on top, I have 2 square roots of 3. And on bottom, I have the square root of 9, which is 3. So my answer would be that. Yes. Tangent is sine divided by cosine. So yeah, we do need to do one with tangent. This one's the big, it's not hard, but yeah, I mean, it's tricky because it's a lot of algebra. So let's do this one, and then I'll let you work, okay? We're not doing this whole worksheet, so just stay with me, guys. So it says, find the exact value of cotangent of pi. So I say to myself once again, what is cotangent of pi? Well, that's 1 over tangent, right? 1 over tangent of pi. So really, isn't that, we know that tangent is sine divided by cosine, right? So we could look at this as 1 divided by, tangent is sine, so we're doing sine of pi divided by cosine of pi. Does everybody see how I rewrote tangent as sine over cosine? Is anybody confused? Okay, so then let's locate pi. It was positive pi, so it's right here. So we're doing sine, which is 0, right? Divided by negative 1. So on top, we still have our 1. Then divided by, this became a 0. This became a negative 1. Now, before we start doing anything, let's say, okay, what do we have on top? 1 over 1. And on bottom, we have 0 divided by negative 1. Does everybody see how, okay, this I'm rewriting as 1 over 1, because 1 is 1 over 1, right? Then I'm rewriting the bottom as, I mean, it's the same thing. Do you see? It's just helping me simplify it correctly. Then dividing fractions is easy as pie. You flip the second fraction and multiply. So we're going to flip the second, so it's going to be a negative 1 on top and a 0 on bottom. But do you see how my algebra is working out here? It's coming out pretty, but I'm really good at algebra, so you've got to go through these steps and not skip. Okay, what's 1 times negative 1? What's 1 times 0? Can you have a so we have negative 1 divided by 0. If you try typing that into your calculator, it will say error, because can we divide anything by 0? No, so this would be undefined. But guys, just because you have 1s and 0s, doesn't mean it's going to be undefined. If we wouldn't have been dividing by 0, what if our 0 would have ended up on top? What's 0 divided by negative 1? 0. So do you see how sometimes it might come out undefined or it might come out to be 0? Yes.
So if it's like all the time, if it's in the denominator, then it's undefined. But if it's in the...
Right. If you're, yeah, as long as you simplified it completely. So because 0 ended up in the bottom, that's undefined. Yeah, good questions. Okay, so do problems 1 through 8. Ready, set, go. Algebra, algebra, algebra. Let's say you have this. 2 divided by, you'll want to watch this. This is an example that will hopefully help you. Let's say I said simplify this. 2 divided by 2/3 divided by 3/4. Okay? Is everybody looking with me?
Yes.
Okay, so we're dividing. Now you have to look. What's kind of connected? Isn't 2/3 2/3?
Yeah.
Isn't 3/4 3/4?
Yes.
And then we have a 2 over 1 technically on top, right? Okay, what I'm going to do is simplify it in sections. So I'm going to work from the bottom up. I'm going to focus on this, ignore the top for a minute, and simplify. So dividing fractions is easy as pie. Flip the second fraction and multiply. So we would have 4 over 3, right? You see how I'm just focusing on this piece? So then this is gone, and we have 8 over what? 9, okay? So really now we have 2 divided by 8 over 9. Does everybody see that? Are you still following me? Because your algebra is not there. So then technically, don't we have 2 over 1 divided by 8 over 9? So dividing fractions is easy as pie. Flip the second fraction and multiply. So now I'll take that, put a 9 on top and an 8 on bottom. Does everybody see what I'm doing here? Okay, so we have 18 over 8. Okay. So see now if you can simplify number 2 correctly. Work from the bottom up, just like I did here.
So what I did first is I took... Oh, it won't write.
Haven't you seen her do this 50 times?
Okay.
Oh, there it goes. Okay. So I took 1 over sine of 2 pi. That's 3. 2 pi thirds and then that's also over cosine of 2 pi thirds.
Okay, pause there. Does anybody have questions up to here?
And then, so I went 1, and then I figured out that the sine of 2/3 is y, which is that, so it's square root of 3 over 2. And then the cosine of it is that, so it's negative 1 over 2. And then, like she did the bottom and worked up. And,
Speak English, don't laugh at my teachers. Come on,
Maybe he should kneel to write it.
Hey, if you circle it and tap on it at all.
Okay, so guys, as he's going, questions. Do you understand where he put this in up to here? Well, what's your question? Ask it. This is sine, this is cosine at that value.
I don't make a question.
Okay,
questions?
click on the pen again.
Okay, so you work up, and then so you do dividing fraction, easy as pie, flip this one, and multiply. So square root of 3 over 2, and then times that by 2 over negative 1. Okay, yeah, I'm right. And then those two go out, and you do square root of 3 over negative 1. And then technically you had a 1 over a 1 on top. So then you times this by 1 over 1. And then you do the same thing. You have to flip this one. So it's negative 1 square root of 3 times that. And then that would be negative 1 over square root of 3.
Okay, pause right there.
And after that, you have to do it different because that's not acceptable. And so that equals 3 on the bottom, and then negative square root of 3. And she told me you wouldn't put 9. So
Yes, it's only 9 if it's under a square root, right? Was our negative under our square root? No. Okay. So that's our answer. Awesome.
We got it, baby.
Yes. Continue working. All right, so everybody, grab your calculators. We're going to calculate these, not exact. Okay, I'm screaming, people. Listen. So, we're going to use our calculators to now find the decimal approximations. Why do we use the unit circle? So we can find exact values. But sometimes you're going to have something not on the unit circle. So we're going to just use our calculator. Pull it out. Now make sure, because does everybody see how this is in degrees?
Yes.
We have to make sure our calculator is in degree mode. So everybody hit the mode key on your calculator. Hurry, mode. Change it to degrees, not radians. Now calculate. Well, first of all, we have to think about what is cosecant. Isn't that 1 over sine, right? So we're really doing 1 divided by sine of 50 degrees. Just type it in your calculator. 1 divided by sine of 50 degrees. Type it in. What's the decimal?
1.30.
1.331. Okay, awesome. Does everybody see how to do that? It was super easy, just using your calculator. So look, it's in degrees, so my calculator has to be in degree mode. What is secant? 1 over cosine, right? So you type in your calculator. 1 divided by cosine of 60 degrees. So type it in. You get 2. Very good.
I'm out, but if it's cotangent.
So if it's cotangent, you would do 1 divided by sine divided by cosine of that value. And we would make sure we group the sine and cosine in parentheses.
Wait, you can't just type in tangent?
Oh yeah, you can just type in tangent. So we get the same answer.
Wow.
We get the same answer, but why make it harder on ourselves? There's a tangent key.
Yeah.
Yeah. Okay, so look at this one. Now look, here's the problem though. Do you see how this one's in radians? Change your calculator to radian mode to calculate this. So we have to know what is cotangent. That's 1 over tangent. So you'll type in 1 over tangent of pi divided by 6. You cannot type in 3.14. Use the pi key on your calculator. Make sure it's in radian mode. But you just type it in. Did everybody practice that? 1.73. So then cosecant of 2 is 1 over sine of 2. You type it in and you get whatever. Does everybody see how to do these?
Yeah.
So if you couldn't do the algebra ones, you could get the whole assignment done except for the top ones and then come get help. Okay? This is what's due on the worksheet. 20 through 27. 29 through 34, I don't want you to graph. Just list the amplitude, the number of cycles, the phase shift, and vertical shift. So super easy. This is all that's required. Anything else you can cross out. But besides the top, right? The top is required. I already assigned that. And now these. So
we don't even have to do 9 through 16.
no. Do. Wait, yes? What's like, right. Add 9 through 16.
Schneider. The whole page. Everything but 28.
So everything except for, you won't be doing 17, 18, 19. You're not doing 28. You're not doing 35 through 36. And if you read my directions, I'm making it easier on you. I'm not making you graph any of that. All you have to do is list the amplitude, the number of cycles from 0 to 2 pi, the phase shift, vertical shift. Then come get help on problems 1 through 8. I guarantee if some of you will sit down one-on-one with me, you'll get those all right.
Yep.